Yeah, so thanks everyone. This is actually my first exposure to any of this ad tree stuff. So it's been amazing to see everything that's been going on. I want to sidestep a little bit into recreation modeling. So it's one of these ecosystem services. It's going to be included in the final models alongside everything else. But I just wanted to go into a little bit more depth on what we've been working on, specifically on ORVal. So for those of you who haven't come across ORVal before, it's an online tool. Anyone can sort of go on and have a look at a map of England and Wales and click on the sites and see how much value they've got and how many different people we predict would visit each one of those sites. And you can do some extra stuff, creating new sites and changing the characteristics, that sort of thing. Because it's a tool, we don't, in the traditional sense, have results. You know, we've messed around with some of the internals and things, but I want to focus a little bit more on how we're actually approaching this problem. The sort of nuts and bolts underlying ORVal, especially because I know some people in this room are going to be working quite closely with some of that modelling underneath. So the core of ORVal really is like this per person per day discrete choice model. So for every person in England and Wales, and maybe in GB as we go, for every day of the year, we're predicting how they're going to make two choices. The first thing is, are they going to go out, leave the house, and go to a green space site? And the second is, okay, if they decide to go out, which site are they going to choose? They've got all of the ones in England and Wales to choose from. So which one are they going to go for? And to tackle that, we obviously need quite a lot of data, which is broadly divided into these two things, which I'm going to talk about a bit more detail. The first is a green space map. So we need to know what options people have got, what options they're choosing between, and also where people actually choose to go. We need some sort of actual data about what choices people are making. So I'm going to start with the green space map. This has been a huge amount of my life over the last few months, so I'm going to try and keep it brief, although I might struggle. And at a sort of big scale, this is what it roughly looks like. Everyone else has been doing these sort of nice maps of the southwest. I've gone for the slightly more narcissistic approach, I'm afraid, and this is just where I grew up. So this is like the south of Birmingham here that you can see, and I grew up somewhere like around there. But you can see broadly, I've got all these different colours and different polygons and things, and these are how we've divided up green spaces into some different categories. The first one of these is parks. You know, parks is quite an intuitive definition, surprisingly hard to do with data in some ways. But these big specialised, highly managed areas, you know, we kind of talk about them being mown. These big open spaces of mown grass where people go and do all sorts of recreational activities. We get that data from OS, and we supplement that with some open source data from OpenStreetMap. I don't know if you've come across it. And when we sort of run everything out, we get about 52,000 of these parks in GB with quite a substantial area actually. The next sort of category that we divide them up into is these recreational natural areas. So these are sort of these more natural recreational experiences that we're talking about. So they're generally areas of natural or semi-natural land cover, and they're more accessed through the paths network. So whereas in a park you might wander all over, you might go and play football in the grass, in these sorts of areas we're kind of suggesting that you're a bit more restricted to the paths. So again, we get all this paths data in. We've done some quite interesting stuff with Strava data to try and figure out which paths people actually use. We've also done some Leiden clustering to get to these sort of really dense clusters of paths, which we think represent something meaningful in terms of recreation, and also go through natural areas. We've also divided out waterside paths, so all these paths that have some sort of waterside experience, and also the sort of rural paths. So these are often the sort of things that people might go for a walk on the countryside. You're just walking through these mostly open fields. You might go through pockets of other land covers and things. And these end up being really significant. There's over 275,000 kilometres of these in GB. And we also do beaches. That's not in South Birmingham, believe it or not. If we did have beaches in South Birmingham, they would probably look like that, I would imagine. But again, they're sort of quite an intuitively distinct recreational experience. Surprisingly, comparatively few, quite hard to define based on just sort of graphic data and things like that. So we're using some designated bathing beaches to define those. So yeah, we've got about 500 in there. So when we kind of put that, we end up with the full green space map, and that's sort of our choice set in the model. So as I said, people can choose to visit any one of these sort of green space sites in GB. I should also mention actually, this is all for ORVal 3, which is currently ongoing, the later version of ORVal. Some of the other bits, I'll try and make that clear as we go along, is from ORVal 2, which is the version of it that's currently online. So this is all going to be in the new one when it comes. So when we've got all those sites, we also need to know something about what their characteristics are. So land cover is obviously a really important one. We use the UKCH data for that and supplement it with some other data sources, specifically about woodlands has been really big in this. We take all the designations. I think we're up to about 25 different designations so far. That's all your SSSIs, nature reserves. We're trying to include more cultural and heritage things in that. So things like scheduled monuments, aesthetic areas, conservation areas, things like that. We're also bringing in facilities where these places have got car parks and toilets and cafes, whether you can get there by public transport, and also then points of interest. So these are all sorts of different things taken from an OS data set. It ends up being, so that's like a war memorial, and that's a big obelisk. So yeah, all sorts of things. So that's the green space maps. We've got all these sites and we know something about each of the sites. We also need some data about where people actually go. I'm not going to spend too long on this. This is mostly from these two surveys. So the MINI survey, Monitor Engagement with the Natural Environment, which ran from 2009 to 2019, and then PANS, People and Nature. And basically, these surveys do a lot of things, but one thing that they do, which is really useful for us, is they ask people to tell us in quite a lot of detail where they went for a green space visit on one day. So they say where they started, what their home address was, where they went. We have a bunch of information about their sort of, like their personal data, their gender, whether they've got a dog, whether they've got children, all those sorts of things. So that's a really amazing data source. So I think it's well over 100,000 records we've got in there. It is limited by day trips only, so we don't capture holidays where people take, you might stay in holiday cottages and go from there. Again, from home, and it's also for over 16s only. Okay, so that's the sort of underlying data that goes into ORVal. That's all ORVal 3 stuff. So I'm now going to talk a little bit more about the actual model that's underlying it. And this is, I will admit, we haven't actually made too much progress on this with ORVal 3 yet. So this is based on my understanding of ORVal 2, which may or may not be comprehensive. And Brett, feel free to interrupt me if I've got any of this wrong.
No chance, Jay.
So there's a few key concepts introduced. So the first one is that all of these sites have got some sort of utility, and that utility is a function of the characteristics of that site in some way. So if you've got X amount of woodlands, X amount of grass, each one of these contributes somehow to that utility. And as you add more of those things, you get more utility, is one of the assumptions we're looking at. The other thing is that not necessarily all of that utility is realized. So you can get all the value based on these different characteristics, but there's also a travel cost to visiting all of these sites, whether it's fuel or the time it takes to walk or travel. So actually the sort of value that you realize and what the actual value that we're going to report is the difference between those. It's that top grey section there. Another concept which is really important to note is that actually the value of a site and the probability of visiting a site is dependent on the other sites that are around you. There's some extent of substitutability. So if you have a park near you with a big open area, lots of grass, and someone puts another one in near you, it's not going to make a huge amount of difference as if that site was a woodland, because the two parks are quite substitutable, whereas the woodland is not really equivalent to the park in some way. So that's the other thing to note as we go through. Okay, so let's talk this through as a sort of simplified version as an example. That red dot is actually my house, my parents' house. So I'll do like a Sunday afternoon at mum and dad's house, what they might be thinking about. So they might decide to go up here to Cofton Park. So Cofton Park is this really big open area. The dog really likes it. it's got a few little trees scattered about, but mostly it's this big sort of open grassy area. And if they choose to go there, that those qualities of that site feed into the utility, but also the travel cost of them going there. That road's a bit of a nightmare, actually. There's always roadworks. So, they are making a choice to visit that site, and therefore what they get from that site must exceed the travel cost. Alternatively, they might choose to go up there to the Lickies. So the Lickies is a big woodland. Really, it's got like quite a nice cafe and playground and stuff like that, and really good views over Birmingham as well. So again, those characteristics, if they choose to go to the Lickies over Cofton Park, then there's something about that set of characteristics which means that they have got a preference for that site, and they're willing to incur the extra travel cost of going through that really tiny road there to gain those benefits. The other option as well is of just stay at home and do nothing. When Brett's presenting this, he always says staying at home and watching Love Island. That's obviously something he gets a lot of utility from, but you can substitute that out from for whatever other activity you wish. But yeah, again, that's that sort of element of you choose whether to go or not. And eventually you can sort of extend that out to all the sites in the area or across England and Wales. But then you can also start to think about other people as well. So we do aggregate slightly to local super output area, and there's some groups within that, but you can start thinking about how all these different people make these choices to visit all these different sites. So just to formalize that a little bit further, this is the sort of utility function for a person I choosing site J time T. And the first bit to note is this XJB. So the XJ is all of these characteristics that we're talking about. So all these characteristics of the site, so things like the land cover, the designations, points, all those things that I mentioned. And this beta is just a parameter that we estimate. The other thing to note here is this travel cost. So the travel cost is in pounds, and this gamma is a really important one to just note, because that's what if it's effectively a conversion parameter from pound money to utility. So with that travel cost estimate, we can sort of say for every additional pound in travel cost that you would say, you get X amount of utility, and that's translated by that gamma. So that's quite an important one to sort of note. We'll come back to that later on. So that's to choose between the sites, and we also have this element, as I've said, of whether you choose to go or not, which we think is a function of all these different characteristics which we get from the survey. What time of the year it is, your work status, sex and age, whether you've got children, whether you've got a dog, your socioeconomic segment, and again, this is the same. All of that's captured within those Zs. So the final part to note is just about the errors. So we don't assume that these errors are just completely randomly distributed. We assume that there's actually some sort of similarities between these errors, and that's kind of the substitutability concept that I mentioned. So we pull these errors from a random distribution, but they are more similar for the types of sites, so those parks, recreational natural areas that I mentioned, and also in these sort of different land use types. I think we also do whether they walked or whether they went in a car. I think that's the main sort of ways in which we group those things. Okay, so we've got that sort of utility function with all those errors, but what's important is what we can then do with that. The first thing is we can start to predict how many people visit each one of these sites. So for a single site, the probability of a person visiting that site is the utility they would get from visiting that site over the utility they would get from all of the other sites, basically. And again, you can calculate those probabilities for all of the sites in the data set, and then you can also calculate those for all people. So you know the probability of every person visiting every site, and you can start to work out how many people actually will visit each one. The other one, which is essentially more important for a lot of people in some cases, is to actually convert that to a value. So based on that entire choice set of sites, you can calculate expected maximum utility, and that's sort of based on the distribution of those errors that we talked about. It's derived from that. I haven't put the equations in, but if you do want to know, I've got them somewhere. Or ask Brett, he will also know. But that's basically the utility across all of the entire choice set. And you can then start messing around with removing individual sites, and you see how that changes, and you can get a utility for individual sites. And when you've got utility for that individual site, we've also got this gamma which converts utilities into pounds, and so we can combine those two together and we end up with a value for each site. Okay, so that's a bit of a whistle-stop tour of ORVal. I've tried to keep it fairly light, but I just want to leave you with that. So it's ORVal is this per person, per day, discrete choice model that every person every day is making these decisions. You can predict the number of people that go to every green space site, the value that is generated by each site. But perhaps most importantly for our trees, using that framework, we've got that modeling framework, you can predict how changing the characteristics of each site would impact its visits and its value. So whether it's converting a chunk of that site from grassland to trees, for example, or predict the value of entirely new sites. If you were to add in a new woodland somewhere, how many people would visit it, what value would they get, how would that change the value of all the other sites which are in the area. So yeah, that's me. Thank you.